What's up everybody and welcome to a new video. And in this video we're gonna start to go over my notes for the miscellaneous topics here with respect to the data structures. So what are those topics? They are indexing, slicing, nesting, multiple assignment, mutability, and then lastly comprehensions. So let's start here with indexing. So the purpose of that is to access individual elements or items from a sequence, i.e. to access individual elements or items from lists, tuples, or strings. And here you can use either positive indices or negative indices. So let's start with positive indices. So to show that, I've prepared here these sequences. So here we have a list that contains a 2, 4, and a 6. And now let's say that we want to access here this first element, which is this 2 here. So therefore we then simply say sequence, and then we use brackets notation. And now to get this first element, and we actually need to use the index 0, because the index here starts at 0. So now if I run this, then we get here this 2. So now let's also get here this 4. So therefore then we simply use the next index, which would be then a 1. So this way we get this 4. And then lastly, let's also here get the 6. So if I use the index 2, then we get here the 6. So now let's also see what happens if we try here to get the element at index 3. Namely, in that case, we get then here an index error because the list index is out of range. Because with index 3, we try to access the fourth element of a list. However, we only have here 3 elements. And the same thing here also works with tuples. So here I have a tuple that contains 3, 5, and 7. And now if I run those cells again, then you can see we get here the 3, 5, and the 7. And then here again, we get an index error where the tuple index is out of range. And lastly, this also works for strings. So here we have a string dog. And now if I run those cells again, then we get here the D, O, and G. And here again, the index error where the string index is out of range. So this is how you can use positive indices. So now let's see how to use negative indices. Namely, with those, you can access the elements of a sequence starting from the end. However, here you actually need to start, or the index actually starts at 1. So if you want to access here this G from the string, then you need to use the index -1. So now if I run this, then you can see here we get the G. And then here if I say -2, then we get the O. And here if I say -3, then we get this D. And then let's also again see what happens if we try to use here -4. Namely, in that case, then we again get the index error because the string index is out of range. And obviously this also works here for tuples and lists. So let me comment out the string here again and then run those cells again. Then we get here 7, 5, and 3. And then lastly, let's also see that for the list. So that here we then get 6, 4, 2, and then here again this index error. So that's how you can use negative indices. So now let's go over the side note here. Namely, that states that unordered collections can't be indexed, i.e. dictionaries and sets can be indexed. So to show that, I have prepared here this dictionary and set. So here we have a dictionary containing the keys 1 and 2. And now let's say that we try to index this dictionary. So therefore then we say here dictionary and then brackets 0. So let's say we want to access this first key value pair. So now if I run this, then you can see that we get a key error because the key 0 doesn't exist. Okay, so now let's do the same thing for the set. So now let's here set and then brackets 0. So we try to get this first element here, so the 1. And now if I run this, then we get here a type error because a set object is not subscriptable. Okay, so that's the side note. And with that, now we've covered what indexing is for and how to use it. Then the next note is about assignment, and this works only for lists since they are mutable. And we'll talk about mutability in a later video, but now I just want to show what this means here. Namely, therefore, I have prepared here these variables. So here we have a list, a tuple, and a string. And now let's say that we want to change this first element of this list here. And let's say that we want to transform it into a 99. So therefore, then we simply say here list, brackets, and then 0. And we set that equal to 99. So now if I run this and then print out the list, then you can see that this element here has changed to a 99. And now let's try to do the same thing for the tuple. So let's say tuple brackets 0, and this should then be equal to 99. So now if I run this, then we get here a type error because a tuple object does not support item assignment. And now let's also do the same thing for the string. So here string 0, and that is equal to 99. And then if I run this, we again get a type error because a string object does not support item assignment. Okay, so this is how assignment with indexing works. So now let's go over the side note here. And this is about zero-based indexing. However, this will get its own video, so I will cover that in the next video. So with that then, we've covered already all my notes for indexing. So now let's go over my notes for slicing. Namely, the purpose of that is to access a slice or part of a sequence, i.e. to access a slice or part of lists, tuples or strings. And here you have a basic notation and a step notation. So let's start here with the basic notation. Namely, therefore you access the sequence, and then here on those brackets you define a start and an end. And those are then simply separated here by a colon. So to show that, I have prepared here these sequences. So here we have a list that goes from 0 to 9. And now let's say that we want to access a slice of this list. Namely, we want to access only those three numbers here, so 3, 4, and 5. So to do that, you would then say here sequence, and then brackets, and then you find start. So that would be in our case 3. And then you also define an end. So let's say here we use the 5. In that case, however, we only get those two elements, so the 3 and the 4. And that's because this end here is not inclusive. So if we also want to get the 5 here, then we need to use a 6. And then we get here the slice that goes from 3 to 4 to 5. So this is how basic notation works. However, here you can also leave out either the start or the end. So for example, if I leave out the start here, then we get this slice. So this means then simply that we want a slice that starts at the first element and then goes up until this end here that we've defined. You can also do it the other way around, where we delete here the end. So if I run this, then we get the following slice, which starts at the 3. So it starts here at the start that we defined and then simply goes until the end of the sequence. And you can also leave both out. So for example, if I leave out here the start and the end, then we get here the whole sequence. So this is how this basic notation works for lists. However, this also works for tuples. So if I use here the tuple and then run those cells again, then we get these results. And this also works for strings. So now if I run this again for the strings, then we get here these slices. So this is how basic notation works. So now let's see how a step notation works. Namely, here we define a start, an end, and then a step size. So to show that, let's again here use just this list here. And then let's say that we want here a slice from 3 to 9. So if we don't use a step size, then we get here this slice. However, now let's use here a step size and let's simply set it to 2. So in that case, then we get here the numbers 3, 5, and 7. And for the step size, you can also specify a negative number. So therefore then we have to use different starts and ends. So then here we have to say we want to go from 9 to 3. And then the step size is -2. And then we get here these this slice here where we have the 9, 7, and 5. And here you can also leave out the start and end. So for example, if I copy this cell and then here delete the start and the end, then we have this notation, and then we get here this slice, so 0, 2, 4, 6, and 8. And we can also do that for negative step size. So if you put in here -2, then we get here a 9, 7, 5, 3, and 1 slice. So this is how step notation works. So now let's go over the side notes here. And the first one states that indices and slices can overflow. So to show what I mean by that, let's first here delete those cells. And then let's use this list here again. So now here, if I say, for example, sequence brackets 99. So if I want to access the element at index 99, then we get here this index error because the list index is out of range. However, if I now create a slice here where I say I want the slice to start at -99 and to go until 99, then we don't get here an error and we actually get then back the whole list. And this also works when you, for example, don't use the start here, or it also works when you don't use here the end. So this is what I mean by the fact here that indices and slices can overflow. Then the next side note states that slices can be empty, and you can achieve that in different ways. So therefore, let's use here again this list. So one way of creating an empty slice is to say, for example, sequence, and I want to start that from at 3 and then also end at 3. So in this case, then we get here this empty slice. So that's one way of doing it. Another way would be to say, I want a slice that starts at 6 and ends at 3 without specifying a negative step size. So if I run this, then we also get here an empty slice, and you can also do that the other way around. So if we say here, I want a slice to start at 3 and end at 6. However, I want to have a negative step size, then here we also get an empty slice, and you can also use these overflowing indices. So for example, if I say here sequence, and then I want to start at 99 and then go until the end, here we also get then this empty slice. And the last way that I want to show is here sequence. And then here, if I start at minus 99 and then I want to end at minus 10, then we also get here an empty slice. So this is how you can create empty slices. Then the next side note states that unordered collections can't be sliced, i.e. dictionaries and sets can be sliced. So to show that, I've prepared here this dictionary and set. And now let's say that we want to try to slice this dictionary here. So therefore then we say dictionary, and then we create here a slice that goes from 1 to 2. So now if I try to run that, then we get a key error because the slice here is not a key in our dictionary. So now let's do the same thing for the set. So we're going to say set 1 and then brackets 1 until 2. And now if I run this, then we get here a type error because the set object is not subscriptable. So as you can see, unordered collections can't be sliced. Then the next side note is simply an explanation why the end in slice notation here is not included. And I will also cover that in the next video where I talk about zero-based indexing. So then let's get to this last side note here, which states that if the sequence is a list, then slice notation creates a copy. And to show that, I've prepared here these 3 variables. So here we have A, B, C. A is a list, B is simply set equal to A, and C is set equal to A, where we use here this slice notation. So now let's print out the IDs of all those variables. So let's say here print ID of A. And then let's also do the same thing for B and C. And then here you can see that A and B have the same ID, whereas C has a different ID. So the slice notation here created a copy of this list. Okay, so with that now, we've covered all those side notes here. And with that, then we've covered all those notes here with respect to the purpose of slicing and how you can use it. Then the next note is about assignment. And this only works for lists since they are mutable. So to show that, I've prepared here these sequences. So here we have a list that goes from 0 to 4. And now let's say that we want to change those 2 elements here. So we want to change the 1 and the 2. The way that we would do that is by saying here sequence and then brackets, and then we want to start a slice at 1 and end at 3. And then we say this should equal a list. And now on this list, we can specify the elements that we want to replace here the 1 and 2 with. So let's simply use here underscores. So 1 underscore and another one. And then let's print out this sequence. And now if I run the cell, then you can see that here we have these underscores instead of the 1 and the 2. So this is how assignment with slices work. However, here in this list here, the number of elements doesn't actually have to match the number of elements in the slice. So you can also have more elements or less. So let's see that. So therefore, let's here, for example, put in this list 3 elements. So this time let's use a dot. So 1, one dot second and then the third one. And now if I run this, then you can see that those two underscores have been replaced with those three dots. So now let's also do it the other way around, where we just where we have less elements. So therefore let's delete those and simply put in here a 99. So now if I run this, then you can see that those two dots here have been replaced with this 99 here. And this way you can also delete elements, namely if you provide here an empty list, and then here if I run this, then you can see that now here this 99 and this dot here have been deleted. So this is how assignment works with lists. Now let's see what happens if we use here a tuple, for example. So if I try to run here the cell, then we get here a type error because a tuple object does not support item assignment. So now let's also do the same thing with the string here. And then here we also get an error, a type error, because string object does not support item assignment. Okay, so this is how assignment works for slices. And with that, now we've covered all my nodes with respect to slicing. So now let's go over my nodes for nesting. And here I first have a definition, namely nesting is when data structures contain other data structures. So for example, if I create here a list, so this should equal to a list. And now in this list, I can put other data structures. So for example, I can put in a list, I can put in a tuple, I can put in a dictionary, and I can also put in a set. And then here, if I run this, then we created here this nested list, which contains other data structures. And here you can also go as deep as you want. Namely, instead of just having here this one list, you can also then here have multiple lists. So this is how I define nesting. Then the next note is about the most common use cases for nested data structures, at least in my opinion. And here, for example, what you can do is to create a list of lists. So to show an example for that, I've prepared here this list of lists. So here, this is a list of lists that contains information about customers. So here we have this overall list, and then for each customer we have then an individual list where we first have the name and then an age and then here a newsletter subscription indicator. So that's a first nested data structure. You could also represent the same information here, for example, with a list of dictionaries. So here I've prepared this list of dictionaries. So here we have again a list for the customers, and now each customer here is represented by this dictionary, where we then have here the keys here, name, age, and newsletter subscription, and the values are then here Tom, in this case 32, and then true. So that's another way of representing this customer information. You could also do that by using a dictionary of lists. So here I have prepared that. So here we have a dictionary for the customers, and each customer now is again represented here with this list. So that's a third way of doing that. And then here the last use case would be, for example, a dictionary of dictionaries. So here I have prepared this dictionary. So here all the customers are again represented in a dictionary. And then for each customer, then here we again have a dictionary. So those are, in my opinion, the four most common use cases. And then here I also have the side note, which states that nested data structures provide a very flexible way of modeling real-world things. So in our example here, we modeled here information about customers. Okay, so those are, in my opinion, the most common use cases for nested data structures. So now let's go over these side notes here. And the first one is about indexing a nested list. So to show how that works, let's use here this list of lists. And let's say that we want to access here this first list. The way that we would do that is by simply saying customers and then brackets 0. And then we get here this list. And now let's say that we want to access here this first element of this list. So the way that we would do that is by simply adding here another bracket and then here again saying 0. So this way then we get, in this case here, this Tom. So this is how indexing a nested list works. And then the next side note is about slicing a nested list. So here, let's say that we want to access those first two lists here. So therefore, then we would say here customers and then brackets and then we want to start at 0 and go until the 2. So this way then we get those first 2 lists here. And here you can also use step notation. So for example, let's say that we want to have this first list and this third list here. In this case, then we would say here customers, then brackets, and then we start at 0. We go until 3, and then we want to have a step size of 2. So this way then we get here this first list and then also this third list here. Okay, so this is how slicing a nested list works. And with that, now we've covered all those side notes here. And with that, we've covered all my notes that I wanted to cover with respect to nesting. So now let's go over my notes for multiple assignment. And here, the purpose of that is to store the individual elements of a data structure or string into multiple variables. So to show what I mean by that, I've prepared here this list. And now let's say that we want to store those numbers here into individual variables. So the way that we would do that is by saying here, for example, A equals the list element at index 0, then B equals the list element at index 1, and C equals the list element at index 2. And then let's also print out those variables. So print A, B, and C. And then you can see we have here printed out 1, 2, and 3. And this can be done more easily with multiple assignment. Namely, what you can do or what you can say is simply A, B, and C. Those should equal the list. And then let's also again here print out A, B, and C. So as you can see, we get the same result. So this is the purpose of multiple assignment. Then the next note is about some potential errors that you might encounter when using multiple assignment. And the first one is to provide too many variables. So here, if I say, for example, A, B, C, D equals our list, then we get here this value error because there are not enough values to unpack. So that's the first error. And the other one would be to provide not enough variables. So for example, if I then say here AB equals our list, then again, we get here this value error. And this time there are too many values to unpack. So those are some of the potential errors that you can encounter with multiple assignment. And with that, now we've covered all my notes that I wanted to cover with respect to multiple assignment. So we've reached the end of this video. And then in the next video, we will go over my notes for zero-based indexing. So why Python uses zero-based indexing. So thanks for watching, and hopefully I will see you in the next video.